Going to learn to solve literal equations. And what a literal equation means is that there's going to be more than one variable. And rather than getting x equals a number at the end, you're going to just have the equation rearranged, and your answer will be in terms of the other variables. So for example, the equation ax plus b equals c is a literal equation because the coefficients and constants have been replaced by letters. Literal equations can be rewritten so that one variable is a function of another variable. And that word function, that just means solved for. Okay? So number one, when I say so that y is a function of x, we're going to solve for y. And our answer will be in terms of x. Basically, we're going to rearrange the equation. So we want to get y by itself on one side. So our goal is for the equation to say y equals. So right now we have something being added to our term that contains the y. So just like we would do with a normal algebraic equation, we would subtract that to the other side. So I'm going to subtract and move the 3x over. And that means on the left-hand side I'm going to be left with 2y. And I can't actually combine like terms because they aren't like terms. 8 minus 3x I can leave just like this. Now I have something multiplying my y. How do I undo multiply? Divide. So when you divide, you have to divide every term by the coefficient of y. Every term. This goes away. I have y equals 4 minus, you can write this as a fraction, 3/2 x. You could have also written this as negative 3/2 x plus 4. All right? So basically what we're doing is we're following the directions in the problem and solving for the given variable. It said so that y is a function of x. Solving for y so that it's in terms of x. Alright, so we're going to do the same thing for number 2. We have y up here in the numerator, but it's also in an expression, so we pretend that there are parentheses here. Now the reason we pretend that they're parentheses is because really when we're solving, we're working PEMDAS backwards, right? So if I have, please excuse my dear Aunt Sally, and we're working PEMDAS backwards, we're going to take care of something that's divided, right, before we take care of the parentheses. So we're going to go this way. So I'm going to multiply each side by 2 first. That will get rid of that 2. Then I have 3y plus 18, you can drop the parentheses, equals how much? Robert?
12x.
12x. Now we have to continue to isolate for the y. The term that has the y, right here, is what we're going for. It has 18 being added to it. How do I undo addition? I subtract. And we know they're not like terms, but we're just going to move the 18 over. We're just rearranging the equation. So now I have 3y is equal to 12x minus 18. And then what's my last step to get y by itself? Sydney?
Divide each number by 3.
Each term gets divided by 3. Good. And our final answer, we get y. That goes away. 4x minus 6. Questions so far? We're rearranging equations, and this is something that's very typical that you'll see a lot. Okay, now we're going to take a formula and solve for a given letter, or a given variable rather. An area of a triangle is given by the formula area equals 1/2 base times height. And the problem says solve the formula for the height. Alright, so if I have, I'm just going to rewrite it, it's a little easier to work with it. I'm going to circle the one I'm solving for. Okay? Now, I think I would like to first get rid of the fraction. How do I undo a fraction next to a variable?
Multiply by the just reciprocal.
multiply by the reciprocal, which would, in this case would be 2 over 1 or just 2. So if I multiply this whole thing by 2, then that goes away. And this becomes 2a equals bh. We're trying to get h by itself, and right now it's being multiplied by b. How do I undo multiply? I divide by b. These b's go away. Now I have height by itself, and I can't actually divide 2a by b, so I just leave it like this. 2a divided by b. Done. We're rearranging the equation. Same thing here, we're going to solve it for w. Nadine, what do you think my first step would be?
Okay, so you could rewrite it if you wanted to.
Okay.
You would probably want to subtract the 21 first.
Not 21, it says 2L. Yes, good. Subtract 2L. We have 2L being added to it. The opposite of addition is subtraction. And because P and 2L are not like terms, all I'm going to do is rewrite it. P minus 2L. Nice. Henry, what do you think my last step is going to be? Each term gets divided by 2. And that cancels, and we get W equals, these 2's cancel. You can either leave it as P over 2, or you could write it as 1/2 P minus L. If you had left it as P over 2 minus L equals W, that's fine also. Okay? Alright, we're on to the last one. This is the formula that relates degrees Celsius with degrees Fahrenheit. If you ever travel in Europe and they give you the temperature for the day in Celsius, this is a very helpful thing to know. So Celsius equals 5/9 the degrees Fahrenheit minus 32. And we want to solve for Fahrenheit, for F. So remember that we're working PEMDAS backwards. So this fraction 5/9 is multiplying the parentheses. So we need to get rid of the multiply before we deal with what's inside the parentheses. So I'm going to multiply by the reciprocal of that fraction to each side first. That will cancel here. You do not need to distribute in this case. You could distribute and still solve, but canceling the fraction first is a lot easier. And you can do that because this parentheses makes this all one term. Alright, so we are left with 9/5 C equals F minus 32. And Tara, what do you think my last step should be?
You multiply each thing by not 5/9.
Well, we're solving for F. So you add 32, good. And if it helps you guys, circle the letter and that you're solving for in each step. That way you don't forget. So now we're just rearranging 9/5 C plus 32 equals F. We have F by itself. Now just for a helpful hint, when you are if you do travel to a country where they record temperature in Celsius versus Fahrenheit, 82 degrees Fahrenheit is about 28 degrees Celsius. That's what I always remember. So when they give you the temperature, if it's like 27, you're like, okay, it's a little less than 82. If it's 29, it's a little warmer than 82. That's how I remember. All right, nice job.